Okay, a sand motor is something I saw that was in several books back in the 20s and 30s for boys to do as projects. It is simply a means of storing energy and releasing it over time. So basically what I have here is a hopper, cardboard tube, down to this sand wheel, which is the same as a water wheel, only in this case it uses sand. The purpose of these was to demonstrate mechanical movements, so boys could make things that various mechanical movements. So what I want one for is basically you could operate a small pump, a small fan, an aerator. A lot of uses for a small sand motor. This is just a prototype, just to kind of see what's involved with making one. I plan to make a better one later. Um, Generally, a sand motor, I kind of look at this as something to replace like a solar panel and a complicated battery system. Much cheaper. I try to do everything as cheaply, as simply as possible. Um, I also got to build, these are wooden bearings. I'll show how I did that in the video. And when I say wooden bearings, I mean not wooden housings for ball bearings, but actually wooden bearings. My pulleys are made of plywood, hand cut out with a jigsaw. My belt is a rope that is held together by duct tape. So anyway, also I have the hubs or friction, held on by friction hubs. So basically I got to do a lot of mechanical movements and learn a lot of things here, all of which could be replaced by something better, something more expensive. I just wanted to use this sand motor both to learn how a sand motor works and to learn all these mechanical movements for future projects. Just to briefly show you the way I make pulley wheels or any wheels out of plywood. First, I find roughly the center. This is my gauge here. Very thin piece of plywood. Have a central 1/2 inch hole to fit the axle. And then these pairs of holes are to create a pulley. This would be a larger pulley and this would be for a smaller pulley. Each of these two holes, one represents the edge, it's going to be a little larger. The other represents the center of the pulley. So I will use this to make a larger pulley and this one to make a smaller pulley. You need to find roughly the center. Okay. Once I've found that, I put a Sharpie, something in there to hold the center spot. And I take another Sharpie Okay, so now I have a circle that I freehand jigsaw out. Not the best job in the world, but it will work. So this is using roughly 1/4 inch plywood. So I'll make another this size and 2 more larger than this. Okay, so now for making my pulleys. Again, they're not perfect by any means, but if they're close enough, I think it'll work just fine. So the idea is the 2 smaller ones go in the middle, sandwiched between the 2 big ones, and that makes my pulley. So let's just glue these. Okay. Just kind of smoosh that around. Pull this extra piece out. Okay, this other small one. To make sure everything lines up correctly, put this little sandwich here on the okay, this to be sure that they line up correctly for the shaft. I'll put this down here. Pull the shaft out and put a big old weight on here. Let this dry for a couple of hours. The first thing I'm going to do is to make the fins for my sand wheel. So got a pretty sturdy soup can here. Drawn lines roughly every quarter way around. I need 8 of these panels from the can to make my wheel. So I'm going to cut those from this can. Got a super heavy duty pair of 10 snips. You don't really need any this big, but to cut through this lip requires a pretty heavy duty squeeze. And once I've got them cut out, I'll do my finer cutting of the tin using one of these craft scissors that you can get in any craft store, hobby store. They come in really handy. So, step 1, and please be careful with this. Dealing with sharp tin can be kind of, you can get cut fairly easily. Come back to that one. All right. Does not have to be exact. Okay. As I said, it works real neatly just to fold these. They tend to crease about the right place where I want them. If they don't, you can kind of manipulate it a little bit to get a little additional amount, but I'm just gonna, okay. Now I've made these metal pieces. I just cut off trim off each one. So now they're not exactly the same, but that's fine. They're close enough for my purposes. So I'll take these, and these will be part of my sand wheel. All right, I cut out another 1/4-inch plywood disc. This I cut it out to be roughly 12 inches in diameter, so 6 inches each way. I used the same technique that I used to make the pulleys. As you see, I've marked out at 90 degrees, 1, 2, 3, 4, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, 4 marks. That's where I'm going to put my can pedals in order to catch the sand. and then I split the difference and added one in between, and that is to get me 8 different pedals on my fan to capture the sand. So now what I'm going to do is, about 3/4 of an inch in, I'm just going to take my jigsaw to make a cut to hold the can. Okay, the next step to make these, I've been calling them pedals, vanes, I don't know if it's a windmill or a sand mill, but buckets, whatever works better, is to slide these in here and then hot glue them in place. Okay. Okay, there's the first one. Okay, here is the completed sand wheel. Make sure when we have it mounted in the machine that the concave side faces upward. Okay, I want to very quickly show you how I make my friction hubs here. Some of my projects in the past have not been as good as I would like because I did not have it set up so that the wheel would stay locked on to the shaft. So essentially, let me show you the finished product before I make this one. This is it. Piece of plywood. My shaft is a 1/2 inch shaft. I drill using a spade bit, standard spade bit, a hole, and then I simply jigsaw using a fairly wide jigsaw blade, a little bit to the end. That gives me something I can clamp down with to tighten, friction tighten around the shaft. And I just simply run, I believe in this case it's just a 1/4 of an inch bolt through there, and then snug it by tightening the nut on there. Mike could add a washer. So this is basically it, made from scrap essentially. So here, my first step, here's a piece of scrap from another project I've done. I like to saw from the inside out here. So let me make sure I've got this lined up. Okay, I knew my line was a little off center, but it looks like the sawed line is perfect here. Now I just need to saw this block out. Okay. Now again, this is just a piece of 3/4 inch scrap plywood here. This pretty much has to be 3/4 inch. Anything less will be hard to get this hole to drill in. So ways out here, use a very small bit to start with, okay?
Then you can drill straighter with a larger bit later. Okay, that looks pretty centered. Now I'm going to put a larger bit in. Okay, here's my 1/4 inch bolt. Yes, it's way too long, but I'd rather buy them too long than have them too short. No matter what size I buy, I'll end up using them for something. Okay, now I have a little bit larger bit in here, just slightly larger than a 1/4 inch. And if I tried to do this to begin with, it would not be a straight hole at all. So from experience, drill the pilot first with a smaller bit. Now have a hole fairly well centered. It's a little off. Okay. Okay, and that's pretty much it. So that's what I'll use to friction tighten down onto the shaft. And I can drill over here, put in a couple of wood screws to hold it to my pulley. This project is a learning experience for me that I can scale up into bigger things. So the next thing I need to do is to make some bearings. I bought, and this should be available at any home supply store. The hardwood you'll be able to get is oak. So I bought a 1x3, well, actually more of a 3/4 inch by 3 by, I believe, 24-inch piece of oak. You want to use a hardwood. Pine doesn't generally make good bearings. Oak is not the best, but it's the one that's most easily available. Ideally, some sort of fruit wood like apple, pear, dogwood. I'm going to try more later on, but for right now, I drilled. All of these are 4 inches long by the 3 inches that 3.5 that they came. Actually, I believe it's 2.5. 2.5 wide. I cut them 4 inches long. Drilled the same way I drilled and everything else. Used a spade bit to drill a 1/2 inch hole. I wrapped some sandpaper around a dowel and used it to smooth the inside a little bit and slightly enlarge it so the axle will spin very smoothly. Now I need to soak these in oil. Ideally hot oil, but I'm just going to go ahead and soak them for about 3 days in just room temperature sunflower oil. So just pour that on here. Okay, I'll start these, maybe add a little more, especially to the holes. Tomorrow I'll flip them over, let them soak for about 3 days, and then we'll see how they work for bearings.
Here's my prototype sand motor. Again, to avoid cabinetry, I'm just using a ladder, but this could be built different sizes, scaled different ways. Added these plastic cups, hot glued those onto the can strips to help pick up the sand but carry the weight better. I just have a little homemade fan type thing here just to show that that's the power takeoff, where you could use it to operate a fan, an aerator, a pump, just something of that nature. Again, my wooden bearings, completely wood. This is not wood housing a ball bearings or something. It's all wood, and the wooden pulleys, and I just have a rope used as a belt, and duct tape holding the rope together. Lots of videos on YouTube about how to use heat to kind of weld a rope together. Uh, Using dowel rods here to keep the distance, to keep the tautness of the rope. So that's just that's something when I scale this up to something bigger, I'll have a little more standard way of stretching the belt. But here, for this purpose, that's just a way to do it for a quick test of the motor. Okay, if you're doing this inside, you definitely want to use a mask because sand is very dusty. So let's see what we get here. Okay, I have some work to do to make this a little smoother, but that was only 2 of these football cups full of sand. Uh, so we need to work on my alignment a little bit, but I'm very pleased with how this thing runs. As I said, there's some things I can do to smooth it out, but for a first try, I think the prototype is definitely worth scaling up.